Hello, Aurora lovers. I'm DaleBoan from DaleBoanImaging, and this is Aurora Hunting 101. This is episode 28. What is Stellarium? Stellarium is a simple planetarium app and website that can help you learn a few basics about the night sky to help orientate yourself at night and just learn more about the night sky in general. And it gives you something else to do while waiting for Aurora. You can check out, learn some constellations, all sorts of things. Stellarium has both a free and paid version, mostly in the apps. I think the website is just free. And the free version is fine for general use. My only complaint about it is that it requires a data connection, and I'm often in locations without any cell service. So personally, I use Sky Safari, which is a little more technical, a little more astronomy oriented, and it doesn't require a data connection. It does have, free for Android version for their app, and then I think it's about $3 for the iOS version of the Sky Safari app. It's a little more complicated and fiddly to use, so that's why I'm starting with the free, maybe a little more user-friendly web and its website version that is Sky Safari. So let's take a look at it. This is the Stellarium website, so it's stellarium-web.org, and it's not clear to me if it's a commercial or it's more of a public service. It's a lot of it. I think a lot of the software is open source, so that is why the website is free. And then they're trying to maybe make some money on the apps. So if you really like it, you can always support them. By default, it should geolocate. It figured out that I'm near Saskatoon, which is where I live. I'm, not in the center of Saskatoon. I guess that's why it's saying near. So you can just go on here with your mouse and spin around. So this is looking north. This is the Big Dipper here. And then this would be the North Star. So one of the things you want to do when you first go out, maybe you drive down a winding road and you park somewhere and you're not actually certain where north is. If you can see the Big Dipper, you can figure out where north is. And even if you can just see the Big Dipper, that's going to be close enough to north for most, at least to get you starting photographing the northern lights. But if you, the trick is if you take the two stars at the bowl of the Big Dipper and just follow it out about 5 lengths, 1, 2, 3, 4, 5, you get to Polaris, the North Star, and that's the star that is approximately straight north. The Earth rotates. When it rotates, that star stays pretty much stationary. It's actually a little bit off center, but it's pretty close. So in my mind, that's one of the most basic things that you should know how to do is be able to find north just using the stars. There's another constellation over here called Cassiopeia that looks a little bit like a W, and it is also rotates around the North Star about the same distance away. So the North Star is approximately in between those two. So that's always a good starting point. So if you want to go a little bit deeper into Stellarium, you can do a number of things. Down here is the menus, or the display options. So if I want to see the constellations, it'll draw in the lines for me. So you can see clearly that W for Cassiopeia. You can see the Polaris here is the handle of the Little Dipper. The Little Dipper is pretty dim. It can be, unless you're in a dark sky, it can be sometimes hard to find. But these two stars are usually pretty visible, and this one's reasonably visible. The North Star isn't that bright either, but there, as you can see, there isn't any bright stars around it. So it's sort of in this fairly dark area. And it's about the only bright star off these 2 pointer stars in the bowl. So that can help you. Some people are surprised that the Big Dipper is not a constellation. It's part of Ursa Major, the big bear, and Ursa Minor is the little bear. So the handle is actually the bear's tail. And it's got a funny looking head. Constellations don't really look like what they're supposed to represent. I'm not certain how they came up with these ideas. If you want, you can turn on the art that goes with it. So you can see the bear with a giant tail. You can see the little bear, and you can see the Draco, the dragon. Andromeda's over here. Perseus is over here. So we just had the Perseid meteor shower. They originate from that direction in the sky. But it may be a little confusing to have that on. Turn the atmosphere on and off. So if this would be more of a twilight time. So just after sunset, before it gets completely dark, and then completely dark, you start seeing the Milky Way here. This is the outward part of the Milky Way. The other, if you look south, you see the core on the other side. And you just drag this around like a map, so it's easy to look around and figure out what's south. So if, say, you're out and you want to maybe take a picture of the Milky Way, you can see where it is based on the time. So for some reason it defaulted to fairly late at night. I guess it defaulted to dark time. You can turn off the landscape so you can see the stars that are below the horizon. Like Scorpius is always one of my favorites, but you can't really see it where I live. Sagittarius is kind of cool. You can see this little teapot, usually in the south in the summer. Just get that lid and the spout and the handle here. That's an asterism. That's just part of the Sagittarius constellation. So just like the Big Dipper is just part of the Ursa Major constellation. So the name for those things are asterisms. And there's lots of things. One of my favorite asterisms is the little coat hanger. Here. So if you can find this little diamond, that's the dolphin, Delphinius. This one's pretty recognizable if you look towards the Milky Way. And then right here, there's this. You pretty much need binoculars to see this, but it looks like an upside down coat hanger in binoculars. Right in the middle of this dark patch in the Milky Way. So to make it a little less confusing, let's put the landscape back. So if you want to know let's talk about time, because time is the most important thing. So you can use this slider to see the stars as they rotate. Why are they showing me the ones below the horizon? Interesting. So as through the night, you can see how much the sky rotates through a night. And of course, I'm doing this in the summer, so it's showing me mainly the summer constellations at night. Whoa, come back. So if we look at north, and you can see how everything rotates around the North Star here through the night. That's why it's the North Star. The Ursa Major is down there with the Dipper. Jupiter's really bright right now. If you're watching this, in the next few months. Actually, Jupiter's probably going to be visible into December, would be my guess, maybe even longer. So those are the other key key pattern that's good to know beyond the Big Dipper. Whoa! So if you lay on the ground, look straight up, that's what you see. And let me spin this around. We do have atmosphere. Let's throw some atmosphere on there. Let's get rid of the constellations. So just after sunset or before sunrise, when you can't see very many stars, you can see this pie-shaped pattern. Vega is up here. It's one of the brightest stars. It'll be almost straight up in, through much of the summer around sunset. And if you're interested in finding the Milky Way runs right down through this pie. This is called the summer triangle that people use to orient themselves in the summer when you first go out and look at the stars. And then as it gets darker, it's going to move, but you can see as I adjust the time. So if I take the atmosphere out, you can see how, so this is the Vega, Deneb in Cygnus, and Altar in Aquila form the summer triangle. And if you sort of follow this line down through the middle of it, that leads you straight to the Milky Way on the horizon. So that's a good way of orientating yourself in the summer. The stars in the south are moving and changing much more through the year than the ones in the north. Some of the ones in the north are always there. The Big Dipper is, depending on where you are. If you can see the North Star is always there. If you're far enough south, then you can't see that anymore. And I'm talking purely about the Northern Hemisphere. There is no equivalent to the North Star in the Southern Hemisphere. So if you start, so that you can set the time to whatever you want. So this is approximately, just before 20 minutes before midnight, 23:40, August 30th. And you can see, you could just change this by the months, and you can see how the orientation of the stars changes. And you see that the North Star doesn't really move much. Moves a little teeny tiny bit. Like I said, it's not perfectly dead center. But you can see that like Cassiopeia is still here, the Big Dipper is still here. If you're further south, that'll be lower in the horizon. But if we look south, then we go from August to September. You can see the Milky Way has shifted quite a ways over, and it's lower. And now once we're getting into October, Orion starts rising. So Orion is rising now, but it's early in the morning. So Orion is one of the, or probably the best winter constellations. It's certainly the most recognizable one. You can see these 3 dots pretty clearly, and then there's another 3 dots that mark this is the belt, his belt, this is his shoulders and head. There's a bow here, legs are here, This is his knife or sword. If you do the art, see this sword, the belt, head and shoulders, arm going up there. So that is very recognizable. And if you're taking a picture and Orion is in it, you're probably not going to have Aurora in it. You're probably photographing the wrong direction. I guess if you're very, very, very far north, above the auroral zone, sometimes the Aurora will be south of you. If you're in the middle of the auroral donut, then you're probably going to be shooting south to see the Aurora a lot of the time. But there's not going to be too many people watching this where that is the issue. If we go back to time, maybe zoom back out a little bit, go back to south, and you can see, go December into January, you can see Orion around midnight is actually starting to disappear. The other common constellation that you can see is Leo. So Leo, you can find this question mark, backwards question mark. So if we put the constellation there, see, we have the head of Leo, the lion. That question mark's pretty clear. So it's always fun to learn a few constellations. I still try and learn constellations when I'm out there because there's a lot of really obscure, hard to see ones. Sirius is one of the winter stars. It's very bright and low on the horizon where I live. Probably most places you're going to be taking Aurora photographs. Oops, let's zoom out a little bit so we go back to south. The moon moves around all the time, right? It goes around every month, so where it is changes all the time. And then we're back into spring, and you can see that the Milky Way and Vega is starting to rise in the east. So there's our sort of distorted summer triangle. That's the distortion is just the way this is being displayed. So you got Vega there, you've got Denham there, and Altar, yes. Altar in Aquila there. Oh yeah, and if you click on any of these things, it'll tell you about it. Interesting, a lot of the stars have Arabic names, in part because the Arabs translated some of Ptolemy's maps into Arab in the 700s. And then during the Dark Ages, not much happened in Europe. And then eventually in the 1400s, something like that, or maybe not that long ago, 1100s, it got translated back into, the additional star maps that they had developed got translated back into Latin. So you have this mixture that the constellations are Latin and a lot of the stars are Arabic. So you can play with the time. The other ones in here, so atmosphere is trying to simulate, given what the atmospheric conditions are, especially for twilight, what stars you can see. So you can see the day you can see the moon, and then as you get into twilight, you can often see the planets as some of the first ones, and the stars. Scroll wheel on the mouse zooms in and out. That's how I'm zooming so easily. Come back here. Being south down here and back up. Venus is over here. Venus is always near the sun, either sunrise or sunset. Sometimes you can't see it, but since it orbits closer to the sun than us, it's always fairly close to the sun. Venus or Mercury is even closer. Mercury is actually fairly hard to see. But you can see as it's trying to simulate, the sunset, and you know, over here is not going to be a good place to look at the stars, but over, you know, straight up is maybe not so bad until it gets considerably darker and then more stars appear. And then it, you know, reverses as at sunrise. So you can put, you know, if you're planning a trip, you can put a date in there and see where the Milky Way is going to be on that date. At what time, you know, do you want to try and maybe take a picture? You can put in basically the map coordinates. There's two of them. There's the azimuth grid and the equatorial grid. So that's based on the Earth's equator. I'm not certain. You don't really need to know that. You can have deep sky objects in there or not. Let's go back to, this sets me back to now, which isn't very useful, but we want to say midnight. It'd be easier with a slider. I think one of the coolest things to see is the Andromeda Galaxy, and you can see it with binoculars. Pretty much any binoculars will make it show as a fuzzy patch. And one of the ways is to take Cassiopeia and use those three stars and sort of point out about, I don't know, 4 distances, and it's in that area right there. You can also use the Pegasus square. Let's get rid of the atmosphere. So there's this 4 square of stars there. And if you follow this line of stars, oops, oh, there's a square. There's a square. There's our square. And if you follow this line of stars and go up 1, 2, there's a blurry patch right here. If you look at it with binoculars, you can see something approximately like that. If I turn that off, it doesn't mark it anymore. And if, like, you can take pictures with just a normal camera that look pretty much like that, with a little bit of processing help. And that's another galaxy. That is another galaxy. In some areas, there's galaxies after galaxies, but they're a long ways away. This is the closest one, and it's one of the maybe the most distant thing you can see with your naked eye. You can just sort of tell it there's a fuzzy patch right there if you know where to look. So this will mark those. M is Messier. He identified about 100 objects in the sky that he didn't really know what they were. All nebulas. So a lot of astronomy people, when they first start out, they try to find all of that series. That I think it's 104, 105. Night mode, you can make it red, so it doesn't hurt your night vision as much. And then you can do full screen, and so you don't have the borders around. And there's a few settings in here, but it doesn't have very many settings. You put a meridian line and an ecliptic line. And close. Take it off of night mode. So the ecliptic, or the meridian line, is just the north-south line going straight overhead, and the ecliptic line is the plane of the solar system. Yeah, that's right. So that you can see the planets are all along that ecliptic line. So that's the plane of the solar system, which is different than the Earth's equator because the Earth is tilted at 23 degrees. I think that's correct. You know, Neptune's in there, but Neptune's hard to see even with a telescope. So there's lots of, you know, you can play around with here, play around with this either on your on the website, or download the app onto your phone. And if you're out looking for the Aurora and there's not much going on, you can, you know, learn some constellations, learn some stuff about the night sky. You know, you can click on any of these and it'll pop up information about Jupiter. Magnitude is how bright it is. One is really bright, but it's backwards. So like a dim star is a smaller number, or there's a bigger number. Sorry, a dim star is a dimmer number. So 2.61. This one's maybe brighter. 2.2. Try and click on something really dim. Won't even let me click on it. Anyway, Pleiades, you can see, that's another thing to look at with the binoculars. Binoculars, you might be able to see the moons around Jupiter. I don't know. Depends on the binoculars. Pleiades is reasonably bright. This is the face of this V formation. It looks like a V at night. Is the face of Taurus. It's got a V with a really bright sort of yellowish star at the bottom. There's a million things in the night sky. This has them. You will usually have the, if there's a comet around, it'll show you the comets, things like that as well. Sometimes it's got satellites going over. It'll show you when the space station goes over, I think. Tell you when the planets are visible. So right now the moon's visible all the time. You know, when I'm recording this when the moon is full, so you can see that the moon and the sun are basically opposite of each other. Mercury's really not visible. Venus is visible a little bit in the morning. Mars isn't visible, but Jupiter and Saturn are right now. And those are the naked eye visible ones. Uranus, Neptune, Pluto, you need a telescope or at least binoculars. And even in binoculars, they'll just look like stars. So you need to go look at the map and figure out where is that extra star. And they have the ad right here saying if you want to click for either for Apple or Google Play, download their app. Works very much the same. Or on Play, Sky Safari. This is iOS one. It's $3 US. It's a little more complicated, but it has the same basic ideas. You can turn off the lines for the constellations, or put on the art and things like that. But it does have a lot more technical information. Some of these apps can actually run telescopes. I've never actually tried doing that, but that is one of the options, and that's one of the things that you get as you buy the more expensive versions. Generally, the more expensive it is, the more data it has. So this one's 2.5 million stars, and this one's 100 million stars, 3 million galaxies. So if you're doing, if you're doing astrophotography, you might want that. I don't really have a use for it, but it is available. So that was a whirlwind tour of Stellarium. I think it's a great starting point. I started using Stellarium initially, and the only reason I really switched away from it was I was traveling and didn't have data, or I was in a location that didn't have data and it wouldn't work. I don't know if that's still true, but I suspect it is. So I switched to Sky Safari, which works without an internet, without cell data. They don't have a website, so Stellarium is useful for planning things on my computer. There are correspondingly paid applications that you can download for planetary applications that are sort of sister products to Sky Safari, but on phones as apps. Sky Safari supports both Apple and Android. Yeah, and you can do a lot with just Stellarium. You can change the times and see how the stars are going to move through the night. You can, see how twilight is going to affect the visibility. Helps you find the Milky Way. Use the summer triangle to do that. There's just so much to know about the stars at night. So get out there and enjoy it. With that, check out episode 29. What else can I photograph at night? And I'm wishing you clear skies and happy hunting.